Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, longest alternating subsequence. So what the problem is saying is we'll be given an array, and what we want to do is we want to find out the longest alternating subsequence. So when we say alternating subsequence, right? So what does it mean? So you can also think of as a zigzag sequence. For example, right? Increasing. Okay, alternating in the sense first it is increasing, then it is decreasing, right? For example, 11, then it is increasing, 18, then it is decreasing, right? Something like 15, right? 20, then something like 5, and so on. So here, for example, the first element is lower than the second element, the next element is greater, then the next element of it is lower, then again greater. So in this way, or for example, it can also be vice versa. For example, 18, and then we have 10, then we have 13, then we have something 12, then we have 19, something like that. So if there is a subsequence, right? If there is, so what we want to do is we want to find out the length of the longest such subsequence. Okay, such subsequence, alternating subsequence. Okay, so here when we say subsequence, also it need not necessarily be the contiguous elements, right? For example, here, for example, if you see in this example, right? So what is the maximum length good subsequence is 117. For example, 1 17 10, right? Or here if you say 1 17 10, right? And then we have 13. So if you see, right, so it's not a contiguous element. So we have left 5 over here, right? 10, 13, then we have 10 again over here, right? And then what? Then we have 16 and 8. So in this way, if you see, it's not contiguous. Subsequence means what? Not necessarily contiguous, but in order. Okay, so that's what is the ask here. Okay, now how can we solve this problem? So here, if you see the time complexity, right? The time complexity, what is the time complexity? So if you see, the time complexity here is O of n and space complexity is O of 1. So due to the time constraint today, I won't show you the brute force approach. So the brute force approach is, for example, wherein the time complexity is O of n square. Okay, and we use dynamic programming over there. Okay, but I won't show that due to time constraint. Okay, let me show you the optimized solution here itself. Okay, with O of n as exact time complexity. So what we'll do here is we'll take two counters. Okay, one is increment and one is decrement, and we'll initialize them with 1, because see, why 1? Because there can be an array with one element only, right? So in that case, definitely the answer is going to be 1 only. Okay, so here what we'll do, okay, so we will have two variables, inc and dec, decrement with initialize with 1. Okay, and we'll start with this element. Okay, we'll start with this second element, and we'll check with the previous element if it is increasing, right? So yes, we'll check if it is greater than the previous element. If it is, that means it's an increasing subsequence. So what we'll do in this case, whatever is the decrement value, right, we'll add 1 to it. Okay, so we'll make it 2. Okay, because what we are doing is, first it was decreasing, right? Because first it was lower, and now it is increasing. That is why we are going to whatever it is, right? So whatever was the previous value of decrement or increment, we are going to increment 1 with that. So let's do the dry run. So then what we'll do, we'll check this current element with the previous element. Now it is decreasing, right? Now it is decreasing. So what we'll do, whatever is the increment, right? Whatever is the increment value, will increment with 1. Okay, because you know, right? So what it is saying, so early previous, what it means, so previous it was increasing, now we have got decreasing, so we are going to increment. Okay, we are going to increment that with 1. Okay, again, so now we'll check, we'll go the next element. So here, right, 10 is greater than 5. So here we have found increasing, and the previous, we'll take the previous value, because whatever was the previous length, right, previous decreasing length, right, because it's an subsequence, right, it's an alternating subsequence, so we have to consider the opposites counter for incrementing. Okay, so here what we'll do, here we will increment, right, we'll make it 4. Again, now we'll check for the next element with the previous element, it's again increasing. So what we'll do, since we have found increasing only again, so we are going to take the previous value of decrement only, right? We're going to take the previous value of decrement and increment with 1. So it stays same, because we didn't find the alternate sequence, right? So here it was increasing, again it is increasing here. So it's not an alternate sequence. So the value for the increment will be the same. Okay, again here, if we check now, we'll check with this element, right? Again, here it's an increasing subsequence, right? So this will remain same. This will remain same. We'll do decrement plus one because we didn't find the alternative subsequence yet. Okay. Now let's check the next element here, right? We are going to check with the previous element. Yes, here, right? It's a decreasing we found. So what we are going to do, we are going to take what was in the increasing and add one to it. Okay. So we have found one decrease, the alternate sequence. So we are going to take the increment and plus one we are going to do, right? And then again, now here we'll check the current element with the previous element. It's a decreasing. So it is going to be the same. 4 plus 1, 5. It is going to be because again we have found the decreasing only again, right? Now we'll check this element with the previous element. It's an increasing one. It's an increasing one. So what we'll do, we will take the decrement value and add 1 to it, which will make it 6, right? We'll make it 6. Now we'll move again here, the previous element. Again, it's a decreasing. So whatever it is going to be, we are going to add 1 to it and 7. So if you see, we got the answer 7 and here is the answer 7 here. Okay. So what is the subsequence here? So here 1, 17, 10, 13, 10, 16 and 8. Okay, so this is the answer. Okay, this is the answer and its length is 7. So there can be many subsequences, but one of them is this. Okay, one of them is this. So so this is the intuition behind solving the problem. I hope you've got this intuition. Before going to the code, I'll request you to subscribe to my channel. Thank you so much. Let's quickly see the code here. Okay, so what are you going to do? We are going to take two variables, increment and decrement. Less than air dot length plus I. So we're going to check with the previous one, right? If air of I, it is greater than air of I minus 1, then what are we going to do? That means it's an increasing subsequence. Okay, so we'll increment with decrement plus 1. We are going to, right? The opposite counter, we are going to take and increment that with 1. Okay, else if it is a decreasing subsequence, right? So what we're going to do? We are going to take the previous value of ink, whatever is an increasing subsequence, that is alternate subsequence, and add 1 to it. Okay. And in this way, finally, what we're going to do, whatever it is, right? If it will check the length of both we'll check the length of both the increment and decrement subsequences, right? If anyone, so it can be like out of this two, right? Anyone can be maximum. So whatever is the maximum, we are going to consider that, right? Because I have told earlier also, right? So it may be the case that, see, first we check this one of the subsequences, right? 117, it wasn't increasing. It may happen that one of the subsequences like this, right? 17, 5, then 10, then directly what? 5 again, or maybe we can consider this also. Yeah, maybe we can consider this subsequence, right? After 5, we consider 15 directly, and then 10, right? And then 16, and then 8 like this. Okay. So so the decrease in subsequence also can be maximum, which can start from any other element, right? Need not necessarily from first element. And that is why it can either be increase in subsequence, it can be, or decrease in subsequence. So whatever it is, we'll take the maximum. Okay. Let me submit this. Okay. The test cases seem to be processed. Thanks for watching. I hope you have got the solution. Please subscribe to my channel, like the video. Let's quickly see the C++ code as well. It's the same, right? We have taken two counters, right? And almost the same. Only difference is this max, right? Which is part of the standard namespace. Okay. So this is it. This is it. I hope you have got the solution. Again, please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.